All right. So what I'm going to talk about today are square roots. We'll talk about positive square roots and negative square roots. And where do square roots come from? Now, we know we can construct numbers using prime numbers. For example, if we take 2 times 3 times 5, we can construct the number 30. But what we can also do is we can construct numbers just by multiplying a number to itself. For example, we could take 4 times 4 equals 16. Now, these numbers here are called a prime factorization of 30. But when you take a number and we multiply it to itself, we have to generate a number, we have a different term for that. And what we're going to say is this. We say that 4 is the square root of 16. So because we can multiply 4 to itself to get 16, we say that 4 is the square root of 16. So let me do some examples. Since 5 times 5 equals 25, well, then that means 5 is the square root of 25. So let's take another number and multiply it to itself. So let's say we take 1/2. Well, let's take 1/2 times 1/2. Well, whatever number is going to come out of this, we know that 1/2 will be its square root. So what number is this? Well, we multiply across as we do with fractions, and we get 1/4. That means 1/2 is the square root of 1/4. So we're working with positive numbers, but it also works with negative numbers too. So let's think about this. Let's take -4 times -4. Well, whatever number comes out of this, we know that -4 will be its square root. It turns out that it also is 16. So we find out that -4 is also a square root of 16. So what we're going to find out is this. Numbers have 2 square roots. They have a positive and they have a negative. So they have a positive version and they have a negative version. So let's say we have this. Let's take 2 times 2. Well, again, whatever number comes out of that, we know that the square root is going to be 2, because the square root is the thing times itself gives you that number. So if we do 2 times 2, we get 4. So this means 2 is the square root of 4. But we could also do this. Negative 2 times negative 2 also equals 4. So this means the square root. The square roots of 4 are 2 and negative 2. So this is how we work with square roots. It's a number times itself, and then that's going to be the square root of whatever the result is. We do more than, we're not just going to write sentences out when we do this. We do have symbols. So for the positive square root, we symbolize it with that. We usually put our number goes in here. The negative square root well, this is symbolized with that. So let's do an example. So let's say we want to find the positive and negative square roots of 36. Well, the way we expect the positive square root we write it like that. And what we know, now if you think about our multiplication table, we know 6 times 6 equals 36. So that means this is the square root of 36. And since these are positive, well, we have our positive square root. So that's our positive square root. Now what about our negative square root? Well, we know this. Negative 6 times negative 6 is equal to 36. Because a negative times negative is positive, and 6 times 6 is 36. So that means the negative square root of 36 is negative 6. All right. So that's the idea of square roots. That's what we're going to be working with. And we're going to get into some detailed properties with these as we go through the chapter. So first off, what happens if we have something like this? Let's see here. What do we do here? Now, you might try to take the square root of 25 or the square root of 16 first, but you actually don't want to do that. What you want to do is do the computation inside the square root first. Now, there are times when we don't do this, and we'll talk about that later. But for addition and subtraction, that is something we're going to do. So we're going to compute. Now, when you wouldn't necessarily do the subtraction first, you might factor something out sometimes. So you might factor first before doing the subtraction, if you can even do it, because you might have a variable in it. But what we're going to do is we're going to treat the square root like there's invisible parentheses. And these parentheses are on the inside. So when you're working with square roots, think of them as having parentheses on the inside, urging you to try to do the computation on the inside first. Now, again, we have ways of working around parentheses, so we don't always have to follow the parentheses. And again, factoring is something we can use. Distribution gets rid of parentheses. There's going to be times when we don't always follow this. But sort of a good starting place when working with square roots, imagine there's parentheses on the inside. So that means we're going to do the subtraction first. And so what that's going to give us, 25 minus 16 is the square root now of 9. Now keep in mind, we weren't given a minus in front of this. So we're looking for the positive square root of 9. So what positive number times itself gives you 9? Now you might notice you want some familiarity with the multiplication table. So if it's kind of an area where it's maybe a weak spot, try to find a multiplication table. And you can find the numbers where you have 2 times 2, 3 times 3, 4 times 4, these kinds of things. That's going to help you with square roots a lot. So what 2 numbers multiply to 9? Well, 3 times 3 is 9. So 2 positive numbers that multiply to 9, well, positive number times itself that gives you 9, it's going to be 3. So the square root of 9 is equal to 3. And that's going to be your answer. Now let's say we change things up a bit. Now let's say we have something like this. Well, again, we want to imagine the square roots as if there's invisible parentheses on the inside. Well, on the inside, there are no calculation and no calculation on the inside. So what we're going to do here is we're going to treat the square roots like they're exponents. And so we do the square root first before we do the subtraction. Now, again, if there's those invisible parentheses and there's a subtraction on the inside of the square root, do that first. But since there's a subtraction on the outside, we're going to do the square roots first. Technically, where they fit in the PEMDAS are exponents. This is for positive or for negative. Now we're going to cover that more in the next section. So what this means, we're going to compute the exponents first and then do the subtraction. So square root of 25. Well, we know that 5 times 5 equals 25. And again, we're thinking of a positive square root here. So number times itself gives you 25, is 5. So that means the square root of 25 is going to be 5. Same thing with square root 16. You look on your multiplication table, you'll see that it's 4 times 4 that gives you 16. So the square root of 16 is equal to 4. So now we can simplify this. Square root of 25 is 5 minus the square root of 16. And we're going to get 1. So one of the things we'll ask you to do is treat square roots as a function. And as a function, square root is one of the canonical functions. So f of x equals the square root of x. Now, how to calculate this, what I would recommend is actually start with the outputs and then figure out the inputs. So for example, we know that, well, maybe you don't have to do it quite like that, but we know that 1 times 1 gives you 1. So the square root of 1 is going to be 1. And the reason is that 1 times 1 equals 1. Then I'm going to skip up to, let's say, 4. Now, why did I do an input of 4? Oh, I'm sorry. Yeah, we'll put an input of 4. Well, we're going to be asking for the square root of 4. Well, the square root of 4 equals 2, and the reason is because 2 times 2 gives you 4. And here, I can make this a little more consistent. Square root of 1 is equal to 1, because 1 times 1 gives you 1. Let's put in 9. Now the square root of 9 is equal to 3, because 3 times 3 is equal to 9. So using these 3 numbers, or these 3 points, 1 and 1, 4 and 2, 9 and 3, we can get an idea of what this looks like. So and there's one more point I want to put in. X is 0. The square root of 0 is equal to 0. The reason is 0 times 0 equals 0. So the points that we have, x is 0, f of x is 0. Got this right here. And then we had x is 1 and f of x is 1, because the square root of 1 is 1. And then I jumped out to x is 4. When x is 4, the square root is 2. And then when x is 9, the square root is 3. And so what you get barring artistic license. Well, I'll draw it a little bit differently. You can kind of see what it's doing. But roughly what you're getting is this. A graph that looks like that. This is a little better. There. So this is your f of x is equal to the square root of x. So this is one of those canonical graphs in algebra that you'll be working with in the future. Now, using a function, f of x, that has a square root, we have to be careful of a few things. Note that when you do a square root, we have a number times itself. So we typically take the square roots of positive numbers. And just as a reminder, because 3 times 3 is equal to 9, and negative 3 times negative 3, that also equals 9. So same number, same number. So we have 2 square roots. The reason is, again, we can take 3, multiply it to itself, you'll get 9. Or, in a totally separate operation, take negative 3, multiply it to negative 3, and you get 9. Now, the problem here is, though, with negative numbers. Negative numbers you get from multiplying a positive and a negative. 2 different numbers. I'm being a little specific here using real number, and we'll find out why later. So for positive numbers, we can always multiply a number to itself to get the positive number. And it could be 2 positive, it could be a positive with itself or a negative with itself. But if this was negative, we've got a problem. Because negatives, at least with real numbers, we generate them if we're using multiplication by multiplying a positive and a negative, or a negative and a positive. Negatives and positives are different numbers. Now remember, square root is you take the same number and multiply to itself. It's not a square root if you take a number multiplied by a different number. So for real numbers that are negative, and again, why I'm calling them real numbers, we'll get to figure, we'll see shortly. For real numbers that are negative, there are no square roots. Now, this will get back to why we're studying f of x, but we do need to cover this part first. And it's going to become an important issue when we talk about domain. So negative real numbers like -9 do not have, we should be a little careful here, real square roots. Again, this whole thing with real we'll get to later. So let's go back to -9. So 3 times -3, which is the same as -3 times 3, that's equal to -9. So these are two different numbers, so neither one is a square root. So this is the closest we could get to, say, getting something that looks like it could be a square root, but really it's not. So what we'll say is that the square root positive or the negative square root of 9, and we want to be careful here, there's not a real solution, no real solution, or not a real number. So for now, you can't take the square root of negative numbers. And the reason is, square roots, it's only when a number multiplies its exact self. But we get -9 by multiplying two different numbers. And since we can't come up with a way around that just yet, that's for later, we have to say that there's no number times itself that gives you -9. So we say the square root of -9, whether it's a positive square root or a negative square root, doesn't exist. That's just the way it is for now. So what does this have to do with domain of f of x? So if we have f of x and we have a square root, and we have something in here, some expression, whatever is inside the square root has to always be greater than or equal to 0. It can never be negative. So that's going to be important when we talk about domain with square roots. This can never produce a negative value, what's ever underneath. So let's do an example. F of x equals the square root of x. So what we do is this. To figure out the domain of this function, because it has a square root in it, let's take whatever's in the square root and insist that it's greater than or equal to 0. Well, there we go. We can use values of x that are greater than or equal to 0. So that means our domain is from 0 to positive infinity. Excuse me. Now, let's try something more complicated. So how do we figure out the domain on this? Well, what we want to do is take whatever's on the inside and make it greater than or equal to 0. We insist on it. And so we're going to solve for x. Divide by 3. And since we're dividing by positive 3, it doesn't switch around our inequality. So it gets x greater than or equal to 5. And so that means the domain of this function, for this to never be 0, we have to choose an x that's 5 or greater. And then that's going to be our domain. That's our answer. And then let's try this one. Well, again, same thing. We're going to need whatever on the inside of that square root to be greater than or equal to 0. So we insist, at least for now, not x. We insist that it's going to be greater than or equal to 0 for now. Well, for a function, that's a very different math course in the future. If you have any questions about that, complex variables, let me know. That's another conversation. Divide both sides by 2. We get 4 is greater than or equal to x, or put another way, x can be equal to 4 or it can be smaller than 4. So x is smaller than 4. That means x is to the left of 4. So that means it's on the negative side of 4. And that's going to be our answer. So that's this idea of domain. We want to make sure that whatever is underneath that radical, it's not ever going to become negative, and we have to choose values of x that allow that to happen. So using square roots as functions. So let's say we have this. So let's say we compute f of 18. Well, we replace all the x's with 18. So 18 minus 2. And again, since it's inside the square root, we think of those invisible parentheses. We do the subtraction first. 16. And this is a positive square root. So what positive number times itself gives you 16? It's going to be 4. And that's going to be your answer. Let's do one more. Let's say we did f of negative 2. So replace x with negative 2. Negative 2 minus 2 is negative 4, but we can't take the square root yet of negative numbers. So this has no real solution. Or not a real number. Now, there is something you can use with square roots. There is a way you can involve even negative numbers at this point. And it has to do with this idea. So let's take some notes here. Let's say I take the square root of 5 squared. So 5 squared is 5 times 5 is 25. But since 5 times 5 equals 25, then these are positive. This is positive, so the positive square root of 25 is 5. Well, okay. So let's say we take the positive square root of 5 squared. Well, this will be the square root of 25, the positive square root of 25. And we know what the positive square root of 25 is. It's 5. Well, okay. So square root of 5 squared, it's like the square root and the square cancel out. They just leave you the 5. Oh, it's kind of neat. A little more complicated. Let me show you this. Again, positive square root. And what we're going to do, in fact, before we jump into that, let's say we have negative 5 squared. So that's negative 5 times negative 5. So negative times negative is positive. 5 times 5 is 25. But now this is going to seem a little strange, because what I'm going to say is this. Since 5 times 5, see, I skip the negative here, equals 25, then the positive square root of 25 is still 5. Well, wait a minute, why didn't I make this negative? Let me show you what I'm getting at. Is this. If we take the positive square root of negative 5 squared, then we're going to be asking for the positive square root. Remember, negative 5 squared is 25 of 25. And the positive square root of 25 is 5. Well, this just seems weird. Why am I doing this? Well, let me bring it all together. So we saw that the positive square root of 5 squared turned out to be 5. And then the positive square root of negative 5 squared, that also turned out to be 5. So this is what we're going to get in general. If we take the positive square root of any real number, but square it first, we get the positive version back, no matter what, if this is positive or negative, because we're insisting on the positive square root. Now, if we wanted the negative square root, then this would be negative 5. But if we insist on the positive square root, what goes on the inside, whether it's positive or negative, it comes out positive. This is like absolute value. So this is what we're going to get. In general, the positive square root of any number squared will equal the absolute value of that number. We will always get the positive version of that number. So let me do some examples here. So, for example, the positive square root of -4 squared will come out to be +4. Or to put it another way, if we want to, we could say it's equal to the absolute value of -4, which is +4. It's a better way of putting it. Now, of course, if we do the square root of 4 squared, this will be the absolute value of 4, or just 4. Now again, the square root of x squared will be the absolute value of x, and whatever that turns out to be, depending on what we chose for x. But this is as far as we can go until somebody gives us a number to replace x with. So we'll just leave it that way. It's a little more complicated. If we have the square root of x minus 3 squared, this will become the absolute value of x minus 3. So keep in mind, it's the positive square root of something that's squared on the inside. That converts this whole thing into an absolute value. Now, we can make this a little interesting. So let's say we have this. Now, what do we do with this? Now, we might play with some algebra here, and we can make this observation that if you took 9x squared times itself, you would get 81 x to the 4th. So what we can do is we can rewrite this positive square root of 81 times x to the 4th as (9x squared squared), or 9x squared times itself. And so now we use that trick with absolute value. You take the positive square root of something squared, it's equal to the absolute value of whatever's on the inside of the squaring. And this will be the absolute value of 9x squared. Now, what we can do, though, we can take this a little further. 9 is a positive number. Now, x squared, now again, this is until we get into complex numbers, but x squared, no matter what number we choose for x, positive or negative, when we square it, it becomes positive. Remember, -3 times -3 gives you +9. So this will always be positive. This will also always be positive. That means we're not going to get something negative in here that we have to convert to a positive using absolute value. It'll always come out positive. When we have that situation, we can drop the absolute values. Because 9 is positive and x squared will always be positive, at least until we get to complex numbers. But again, that's another story. Let's say we have this. Well, we're looking at a negative square root here. We haven't talked about this, but if you want, you can take a negative, you can rewrite it, but think of it as -1 times the positive square root of x to the 6. You can think of it like that. So now let's just focus on this. We'll worry about this later. Now you might realize that 10x cubed times itself gives you 100 x to the 6th. So that means we can rewrite this as 10x cubed squared. And so that means the positive square root, as we pulled away that negative, positive square root of something squared, it's whatever's on the inside with the absolute value. Get -1 times the absolute value of 10x cubed. Now for this one, let me just see how they're going to do this. Okay, what you can do is x cubed. If you recall, -2 times -2 times -2. Well, let's take a look at that. So -2 times -2 is +4. +4 times -2 is -8. So here's the point. If we choose x to be negative, we can get a negative on the inside here that we need to use absolute values to make positive. Now 10 is always going to be positive. So we can actually factor out the 10 from the absolute value because it's always going to be positive. And that leaves the absolute value of x cubed. We really don't need to take the absolute value of 10. It's always going to be a positive number. We multiply these together. We get -10 absolute value of x cubed. And this we do need to keep the absolute value because, again, if you put a -2 in for x, you could get a negative in here, and we need to make it positive according to our rule. So this will be our answer. So let me do another one of these. So what we want to think of is this. Two numbers that add up to 14 but multiply to 49. Well, that's going to be x, it's going to be 7 and 7 is what it's going to be. And so we can rewrite this as x plus 7, x plus 7. Or this is x plus 7 squared. Now, once again, we got a positive square root, a square, and then something on the inside. And that means we take the absolute value of whatever's on the inside. And there's nothing positive to factor out, so that's going to be our answer. All right. Now, we've talked about square roots. We do want to look at other kinds of roots. And we will do that in the next lesson.